All right, so now we're going to find another volume of a solid. This time we're going to go about the y-axis. And it gives four curves, one of which is the repeat of x equals 0. I graph y equals x squared. I graphed two lines x equals 0 and x equals 2. And I'm in between those two, obviously. I think x equals 0 is a repeat. And then I graph y equals 4. Everybody, we should be able to see that 2 squared is 4, so we have a point of intersection of the three curves right there. All right. But now, instead of doing the volume about the x-axis of the region, all right, that's the region IC, okay, they want to spin this about the y-axis. And that means that our differential, we're going to cut with our butter knife here, right, to find a of x, but the thickness of that is what? It is dy thick.
There's no washer in this one, is there?
There is no washer. There is no washer. Absolutely not. What is it this time? It is simply, it is just a solid circle, right on. It is a disk is what we're going to call it. So our AY, because it has to be with respect to Y, it has a single radius, R. Now, everybody, here's the problem. Over on this figure, do you guys agree that's the radius? The radius goes to the curve y equals x squared. Now, before I get there, I'm going to leave AB. It's pi r squared, right? That's the... But here's the problem. Does everybody agree this little red arrow I drew here is x long? Right? So I have to figure out... I can't put x in here. I can't go pi x squared. The differential is dy. So I have to change that x distance, because the radius is x, guys. But it goes to the curve y equals x squared. Do you guys agree if you solve for x, it's the square root of y? So I know the radius on this curve this time, because I have to have it with respect to y, is square root of y. Well, all right. And if I'm going to add the differentials, if I'm going to stack up my butter knife cuts from here to here, guys, the limits of integration are not 0 to 2. We're stacking from where to where on the y-axis? 0 to 4, everybody.
Does it say you could have used the x terms? Would it have been like radius equals x squared, or how did you get it?
Yes. If you're going about the x-axis, it would have been raised. All right. So I now have the volume, which I'll write as pi 0 to 4 square root of y squared dy. Oh, I like this problem a lot. Why? Because it's a very simple integration. Does everybody agree? It becomes just y dy. So now I have to do some antiderivative work here. It does not have a plus c because it is a definite integral, not indefinite. All right. So what I get is I get pi times what? Y squared over 2 from 0 to 4. Pi times 4 squared over 2 minus 0 squared over 2. So 16 divided by 2, I think, is 8, right? So everybody, the answer to this problem is 8 pi. That's the volume of that solid. And everybody, I don't know if you can picture this. I'm going to try to draw the picture. Looks like half an egg. I think I did pretty good. And the y-axis is right there. All right? And the origin is right at the bottom of this. It's pretty much an egg shape. All right? And my cross-sectional areas that I added up, there's one there, right? There's another. They're discs, they're solids that are dy thick. And when I add up all those infinite dy's, I end up at 8 pi. Keep practicing.